Hello everyone, this is Professor Jeff Wilkerson at Luther College. Welcome to our What to Look For in the Night Sky video for the week of November 30th, 2020. As you might have noticed, sometimes we look at things that you don't get suggestions for at other places. We'll talk more about that next week when we do. Maybe suggest something that other people are telling you should look for in the night sky. We look for things that are interesting for us for any number of reasons related to the history of our understanding of the universe or whatnot. But again, more about that next week. This week, I'm going to suggest that you look for Algol, the demon star in Perseus. And so I have Perseus drawn here. We'll walk through this a little bit. This isn't quite to scale. I've shrunk the Great Square of Pegasus and Andromeda and blown these things up for you to be able to see this just a little bit. As you've been watching these videos over the last several weeks, you know that we've used the Great Square of Pegasus here in fall of 2020 to help us find the fall sky and to work from there. We're going to do so again now. So you go out after dark right now. The Great Square of Pegasus is high in the south, and there's this cornucopia of stars, this V of stars, that comes off of the Great Square of Pegasus that is Andromeda. And you go a pair, a pair, a pair. And the last star in the bottom row of that pair of stars, of that two strings of stars, is Almach, or Gamma Andromeda. Interesting star in and of itself, but we won't talk much about that here today. We're going to use that as a guide star to Algol. Algol is not too far on across there this direction. And so the next bright star you come to will be Algol as you move out from Gamma Andromeda. All of this is below Cassiopeia up here. So if you find Cassiopeia, the W in the fall evening sky, with the left side as we're seeing it right now, lying down a little bit weakly. So we use Cassiopeia to help find our way around here. We've talked about Cassiopeia in earlier videos. Go back and watch them now to get familiar with this part of the sky. But this is our star of interest. The other star we're going to use as a marker. You keep going. This is a great star to use as well to see this line of stars across here. But instead, if you make a triangle and move up this way, that's the brightest star in Perseus. Perseus is here, and that's Mirfak, the alpha star in Perseus. And so you've got Perseus, looks kind of like a J of relatively faint stars, with Mirfak, the brightest star, in the middle right there. And then a couple of strands of legs coming down this direction. And so, as I've probably told you before, to me, Perseus often looks like a tennis player tossing a ball up into the air and about to serve, about to reach up and serve right into the back of Cassiopeia, right there. And so, if you form this triangle, boom, Algol, boom, Mirfak. Algol is your star right there. Now, what's interesting about Algol? It was the first known eclipsing binary star. Eclipsing binary stars, you got two stars, looks bright. One star, the orbit is inclined just exactly right so that one star passes in front of the other star from our point of view, and it blocks the light from the other star. Gets fainter, 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 brighter, 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 fainter, 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 brighter, brighter, brighter. Full brightness, full brightness, full brightness, full brightness, faint, 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 faintest, and full, getting brighter, 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 full brightness, full brightness, full brightness, and so on. The sketch looks something like this. This isn't for an eclipsing binary system, but it's the right idea is to say you see both stars, you get full brightness. As you move from here to here, it gets fainter, 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 and then it's at minimum light, and then it starts to get brighter, 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 and it's at maximum light again. The so-called light curve, as we call it, the brightness versus time graph looks like this. To say full brightness, full brightness, full brightness, getting fainter, 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 minimum light, minimum light, minimum light, brighter, 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 full brightness, full brightness, full brightness. I like eclipsing binary stars. In the research we've been doing here for 20 years now, we shoot images of the same patch of sky and look at the same 1,600 star systems in there every night that it's clear from late February to early October. And kind of get a sense of what's going on in that patch of sky. And we have discovered about half a dozen eclipsing binaries, very short period eclipsing binaries that we've seen, where this orbit takes less than a day to complete in the systems that we've looked at. And we see these eclipsing binaries and then try to study what's going on. Is mass being transferred from one star to another star in that system? Are the magnetic fields interacting, and so on? And so we're trying to understand the nature of the stars in those systems. Algol about every 2.7 or 2.8 days, Algol completes its orbit and undergoes a deep eclipse like this. There's a really shallow eclipse in between there when the fainter object is obscured by the brighter object, but we'll ignore that for right now. And to say we can actually see Algol when one star passes in front of the other star, we can see Algol get almost 3.25 times dimmer. So it really gets dim. It's really noticeable to the eye. If you're looking at it in binoculars or you're looking at it with your naked eye, I recommend the naked eye because you can't hold binoculars for the length of time you need to. You would see this thing get dim. And it's going to reach minimum light. Algol is going to reach minimum light twice in the upcoming week. Once is at 12:54 a.m. on December 3rd, so that's just after midnight on the evening of December 2nd into the morning of December 3rd, 12:54 a.m. Central Standard Time. So you can adjust that for wherever you are. That's my time. And so that's when I'll be out looking for it if I go out and look for it. And then again on December 5th at 9:43 p.m. it reaches minimum light. And so we will have Algol undergo this eclipse and reach minimum light twice this week, and it gets 3.25 times dimmer. You need to have some comparison stars to watch it get dimmer. Almach's probably your best bet. Just kind of look at those two stars together and see which of those looks brighter to your eye. Mirfak is a good choice, but any of these other stars will work around here to find Algol and see if you can watch it get dimmer. Now, the trick with this, the 3.25 times less bright is really easy for you to see. So this isn't isn't hard to see in that sense. The trick is it takes a while for one star to pass in front of the other star, and so the whole thing takes over 9.5 hours for it to go from full brightness, minimum brightness, back to full brightness. It takes over 9.5 hours, and you probably don't want to sit out and watch it for that entire time. You might. It might be a fun activity. Just nice peaceful activity to kind of enjoy the night sky and think about the universe and watch this over the course of an entire night. But for example, on this December 3rd, December 2nd, evening of December 2nd into the morning of December 3rd, if you started watching at, I'd say 10 o'clock and looked at that and followed that for the next few hours towards 1 a.m., you would see the dramatic dimming during that time. And you wouldn't have to watch it the whole time. You go out, get a picture in your mind's eye of what it looks like, and then go out again and go out again. You're not going to see it as well that way, that dimming, but you should be able to. If you have a setup where you can take a picture of this patch of the sky, you'll really see it in the images that you take. On December 5th, likewise, you could start just after it gets dark. If you start at 6:30 at night or 7 o'clock at night, and watch that until about 10 o'clock. You will have seen a very dramatic dimming of that star, and then can follow it to get brighter if you want to. But those are the things that I recommend this week. Think about how we understand what's going on in the universe. What do we know about stars? If nothing else, I told you some of the things earlier that we're trying to look for in some of these very, very close short period eclipsing binary stars in our system. But if nothing else, this is the way we get direct measurements of the radii, the diameters of stars. How long does it take for one star to pass in front of the other star and move back out? That's related to how big those stars are. And so this allows us to measure the diameters of stars directly, and it's really the only good way we have to do that. And so there's lots of history here. Lots of story about how we understand the universe to go out and look for Algol. So baseline, nothing else. Keep practicing finding the great square of Pegasus, Andromeda, Cassiopeia, and Perseus, and see if you can identify Almach, Algol, and Mirfak here in this region of the sky. And once you get comfortable looking at those stars, keep your eye on Algol. Now, every 2.8 or so days, it's going to keep reaching a minimum. Bam, going to keep doing this. Several days in a row after this, that's going to be during the daytime when you can't see it, but then it's going to cycle back, and you can find that. So go out, give it a try this week. Happy observing, everybody. Hope all is going well.